Kia ora, Year 10. In this video I want to go over what we've done in class so far about how we can use trig to find a missing side length when we've got a right angled triangle. So in this video I'm going to look at the two different situations we get, one which is what we've called the easy one in class and one which is the trickier one. So I've got two triangles here that look very similar but with a couple of important things switched around. I'm going to go through these two examples and then there are two for you to try, and you're going to need to copy down the working into your books as you go. Okay, so when we're doing a trig problem, the first thing we do is we decide if it's going to be using trigonometry or Pythagoras. So in this one here, we've got a missing side length and we've got a second side length, but we haven't got a third side length. So it's not going to be a Pythagoras problem. What we've got instead is we've got this angle here. So we know one of the angles. So we start thinking about trig and we think about labelling our sides first. So let's do that. This side here, the 20 metres, is the hypotenuse. That's the long side of the triangle. We label that as h. We look at the angle and we look out from that angle over here. And this side is the opposite side. The last side is the side that is next to or adjacent to the angle. So this is the adjacent side. So we don't care about the opposite side in this problem. All we want to do is to find x, which is the adjacent side. So then we think about whether it's going to be a sine, cosine, or tan problem. So we look at our SOHCAHTOA and see which two are we linking. And in this one here, we're linking the hypotenuse and the adjacent. So we want to use cosine, CAH. We start by writing down what it is. Cosine of an angle is the adjacent side divided by the hypotenuse. Then we substitute in what we know. Well, we know that the angle is 18 degrees. So we've got cos of 18 degrees is equal to the adjacent side, which is x, divided by 20. Okay, to rearrange this so that we can find x, we undo the division on this side. So we've got x divided by 20. To undo division, we multiply both sides by 20. We get 20 cos 18, or cosine 18, is equal to x. So the cosine of 18 degrees, if you get that out of your calculator, you should see this number, 20 times 0.951057. So how long is side x? I'm just about running out of room. Well, when we multiply those together, we get x is equal to 19.02 metres. I'm going to round that to x is equal to 19 metres. So that's the first kind of problem we looked at. And it was pretty straightforward once we got used to it, because x was in the numerator. And the thing some of us started to do in class today was to solve problems where x is in the denominator. So I'm going to look at that one now, and then you can try a couple of them. So let's get rid of this, and we'll start again. So we start as usual by labelling. Same thing. This is my hypotenuse, the long side of my triangle. The angle's here, so this is the opposite side. And this leftover one here, next to the angle, is the adjacent side. So not surprisingly, I've chosen cosine again, right? So we're going to practice cosine. This time, we set it up and we get cos theta is equal to a over h. We still have the cosine of 18 degrees, but this time a is 20 and h is x. We want to find x. But we're going to start by multiplying both sides by x. Right, so if I times both sides by x, here I get x cosine of 18 degrees is equal to 20. I want to have x on its own, and at the moment it's multiplied by the cosine of 18. So I undo it by dividing both sides by the cosine of 18. We get x is equal to 20 divided by the cosine of 18 degrees. Just going to use some space over here. So now we have x is equal to 20 divided by, what was that number, 0.951057, which gives me an answer of 21.0 meters. So let's just quickly look at why those answers make sense. Well, in the first one, this is the hypotenuse. It's got to be longer than my answer, right? And so in this one here, we found that this side length here was 19.0 meters long. In this one, the next one, we're trying to find this length here. So it's got to be longer than 20 meters, and it's 21.0 meters long. Now I've got two for you to try. Okay, so draw these triangles into your books and then work through them, and they follow exactly the same pattern as the one we've just seen. I'm going to go through them now. Right, so we label, this side is the hypotenuse, this side is the adjacent. We want to use cosine, so we write down our SOHCAHTOA to choose, and we can see the links between A and H. So we're going to have cos theta is equal to A over H, then the cosine of 25 degrees is equal to X over 15. 15 cosine 25 degrees is equal to X. This number here is 15 times 0.906308. That's X. So X works out to be 13.6 meters, and that's rounded to one decimal place. So you should have got X is equal to 13.6 for that one. Right, now let's look at the second one here. So very, very similar to start with. We'll just delete that little bit of mess there. So we do our labelling. This is the hypotenuse. This is the adjacent side. We're linking A and H, so we're using cosine. So cosine of theta is A over H. Cosine of 25 degrees is equal to 15 divided by X. This time the X is in the denominator. We multiply both sides through by it, and we get X cosine of 25 degrees is equal to 15. Next, we divide both sides by cosine of 25. That leaves us with X is equal to 15. Whoops. 15 divided by cosine of 25 degrees. So X is equal to 15 divided by 0.906308, da da da. That gives me a final answer of X is equal to, I think I get 16.6 meters. Right, so I'm just going to go back up and look at how those answers make sense. So in the first problem, our answer worked out to be 13.6 meters. So we did we've lost a bit of triangle there. Never mind, let's put the triangle back in. See if I can draw the triangle side. So our long side in here is 15 meters, right? But we were finding a short side. And our answer here worked out to be X is 13.6 meters. So we can check that that makes sense. It's a little bit shorter than the 15 meters. It's only a little bit shorter because I've got a really squeezy kind of triangle, just like the one we looked at in class. In this next problem, we had to find the long side, and our answer turned out to be 16.6 meters. And again, that makes sense because this side is 15 meters, and this one's got to be longer because it's the hypotenuse. So there you go. Now you're in a good position to practice both types of finding the side length. The first type where we've got the missing number is in the numerator, and the second type where the missing number is in the denominator.